Hey Algebra 2, here is your lesson for 6.3, dividing polynomials. So, quick bell work, divide 313 by 9 without a calculator. I know that most of you have not done long division in a while, so here's your little reminder. It's going to come in handy today. If you don't remember how to set it up, it looks a little something like this. We're dividing 313 by 9. Then all we're going to do is say, is 3 divisible by 9? No, it is not. So we go to the next digit and say 31 divided by 9. How many times does 9 go into 31? It goes in 3. 3 times 9 is 27. When I subtract that down then, I get 4. I bring down my 3 because I can't put 9 into 4. How many times does 9 go into 43? It goes in 4 times. We get 36. When I subtract that, I'm left with, 7. And I'm left with 34 and 7/9. So what we're going to be doing today is essentially the algebraic equivalent of long division. However, we're going to start out with the easiest case of this. And this is case 1 where we will be dividing a polynomial by a monomial. And the cool thing is, because this is just a fraction, remember that fractions that have the same denominator can be broken up into separate fractions. So I can break this up as 24x to the 4th y over 12x squared y minus 12x squared y squared over 12x squared y plus 3x to the y to the negative 1 over 12x squared y. Now, once I have it broken into 3 separate fractions, I can just simplify each one individually. This one is going to be 24 divided by 12. That's 2. The x's simplify to x squareds, and the y's cancel out. So my first term becomes 2x squared, as we saw in our last video. The next one, the 12's cancel out, the x's cancel out, and we're left with just a single y. So I have minus y for my second term. The last one's a little bit harder because 3 divided by 12 ends up being a fraction, so we leave it as a fraction. And then I notice that I'll have an x on the bottom here, and then when this flips down, it'll be y squared. So I will end up with 4... I said 1x on the bottom and y squared. Now I can't simplify or recombine anything to make this look any nicer, so this is my final answer. And that's kind of the nice version of that. However, not that I think the next version is not nice, I just think it takes a little bit more work. So we're going to do the same thing that we did in the bell work, but with algebraic expressions. And we're going to set it up the same way. If I'm dividing x squared plus 3x minus 18 by x minus 3, I'm still going to set up my box the exact same way. X squared plus 3x minus 18 divided by x minus 3. Now, I think some of you saw this in Algebra 1, but if you didn't, that's okay. I'm going to go through it step by step. The first thing I have to know is that I'm dividing x squared by the farthest left term. So how many times does x go into x squared? Well, it doesn't technically go into it at all because I still have that 3 to think about. So I'm going to put a placeholder here. However, I can put x minus 3 into x squared plus 3x. It goes in exactly, I shouldn't have used x as a placeholder anymore because that doesn't make sense. I'm just going to cross that out. The x would actually go over my second term. Now, when I do long division, I'm going to multiply this. The same way that in my original bell work, I multiplied 3 times 9 to get 27. I have to do the exact same here. X times x is going to be x squared. X times negative 3 is negative 3x. However, just as I subtracted up here in my long division, I also have to subtract at this step. X squared minus x squared cancels, but 3x minus negative 3x becomes 6x. You'll notice that x minus 3 does not go into 6x, so we have to bring the negative 18 down. How many times does it go into that? Well, 6x divided by x is positive 6. And when I multiply that back, I get 6x minus 18, which I again subtract, and I'm left with 0. I'm happy with a 0 at the end because it means I have no remainder. Notice in the directions it says verify your division by factoring if possible. The nice thing is we can in fact verify this because the top becomes excuse me, x minus 3 and x plus 6 over x minus 3. And because those are multiplied, we can cancel them out and verify that our answer is just x plus 6. All right, let's see another one here. Same setup. I'm going to set up the box with 3x cubed minus 8x squared plus 16x minus 1, x minus 1 on the outside. Notice you cannot fit two terms into one, so we're going to put a placeholder here. That's lines for me. But it does go into 3x cubed minus 8x squared, and it in fact goes in 3x squared number of times. And I can verify that because when I multiply it, I get 3x cubed minus 3x squared. Don't forget that you are subtracting at this step, so that when you go down, you get negative 5x squared. Bring the next term down to continue the process. It goes in negative 5x times. This becomes negative 5x squared, positive 5x. Per usual, you are subtracting. So 16 minus 5 is 11x. We're going to bring that negative 1 all the way down. It goes in positive 11 times. It's 11x negative 11. Subtract. We get positive 10. And what are we going to do when we get down here? We have a positive 10 and we can't keep going. Well, unlike traditional long division, we can't just add a decimal and keep going. So in this case, if any of you remember your remainders from elementary school, this is going to be the remainder that we put over top of our original, x minus 1. And we say that it is the same thing as adding that remainder. So plus 10 over x minus 1. This one would be significantly harder to verify, so we are not going to verify this one. All right, last one on this page, we have a little different scenario. It says, how do you think you would set up the long division problem for the following? Well, you might think that you're just going to set it up with the p cubed minus 6 in the box. However, because of how long division works, we can't skip the middle terms. Algebraically, we must include the p squared, the p1 before the constant. Now, how are we going to do this without changing the problem? Well, I'm going to do this by adding plus 0p. Technically, I haven't added anything because 0 times p squared is just 0. And then I'm going to do the same thing with plus 0p to get my linear term in before adding my negative 6. And then my p minus 1 goes on the outside. Why do I do this? Well, both because it follows traditional long division, but also when we get to the back side of this paper, you're going to see that our new method requires us to have each and every term accounted for. But I'm getting ahead of myself. Let's keep going. P minus 1 does not go into p cubed, so I placeholder. But it does go into p cubed plus 0p. It goes in p squared times p cubed minus p squared. I subtract, those cancel. I'm left with positive p squared. Bring the 0p down. It goes in one time. multiply again. P times P is P squared. P times -1 is -1P. Subtract again. I have a single P there. I bring the constant down, and I finish it up. How many times does that go in? Just the one time. And then I get all the way to the bottom. Let's see if I run out of room. Yeah, it is -5. There we go. And of course, remember, when we have a remainder all the way down there, we just bring it back up to the top and say negative, because this is a -5, 5 over our original division, the same way you would do with any other fraction. And there's your final answer. All right, now let's flip over and see what's in store for us on the back. So our third case is something I don't think you've seen before, and this is called synthetic division. Now, when I first start showing you this, you are going to be so confused, and that is okay. The methodology behind it is a little bit confusing, but I promise once you see it, you're going to prefer it over long division. So there's a shortcut for dividing polynomials by binomials, like we just saw, when the binomial is in the form x minus n. The shortcut is called synthetic division. And the way that I'm going to set it up is by ignoring the variables and only working with the numbers of the problem. So the way that I'm going to do this is I'm going to say 3, -8, +16, and -1. And I'm going to do a little bit different. I'm going to do upside down long division. But I want you to leave a space right here for another row of numbers, and you'll see why in a minute. The only difference here from long division is that before we would have put this entire piece outside. However, using our shortcut of x minus n, we're only going to use the number. We're not going to use the x associated, because if something is in this form, really simple, with no coefficient in front of x and no exponent on x, we can just take the opposite of the number and put it on the outside. So notice, this was a -1, this is a +1. Now you're like, Miss Bury, where are you going with this? I don't see what you're doing here. It's okay. What I'm going to do is I'm going to start by bringing the 3 down. I'm going to put it right here. And I'm going to start my synthetic division process by not actually dividing, but by multiplying. I'm going to multiply +1 times +3 to get a +3 here. Now, just like I would normally have subtracted down, because we're doing things opposite, I'm going to add down and get a -5. Once I've done that, I'm going to do it again. I'm going to say +1 times -5 becomes -5. Add down to get a +11, and then one more step, +1 times +11 becomes +11, add down, and I get 10. Now, believe it or not, the answer to the problem is right here. We have officially divided this polynomial by this binomial in half the time, but there's no variables yet. So here's where we have to go and put them back in. Because we started off with one term outside, we have to section off one term to be our remainder. So this is going to be what's put back in fraction form at the end. Now you'll notice the same way on the separate page that when I started out with a p cubed and divided by a p, I ended up with a p squared term. The same thing is going to happen here. If I started out with a cubed term, and I'm always dividing by just a single linear term, this first term is going to become the squared term. So this is going to be 3x squared. The next term is going to be linear, minus 5x. Your 11 is now going to become your constant, and because I sectioned that last number off for the remainder, that we put over the original fraction. And that is our answer. I know this seems absolutely crazy, or like I have no idea how you did that. It's okay. We're going to see another one. However, the biggest things that you have to realize when you're doing synthetic division are this. When you have the form x minus n, first, your x must not have exponents or coefficients. If they do, we have to do something a little bit different. The other thing is the number on the outside of division, on the outside of your division problem, is opposite the number inside. So x minus n becomes an n on the outside of your problem. Those are my two big reminders for you. So let's see another one. For the division below, what would you put in the box to do synthetic division? Well, I'm still going to set it up the same way. I create my upside down division. I have to have these each in order. In fact, I'm going to put that as a third step here. Your terms must be in descending and in order. I guess I'll just say in order. So I have to have it in the form x squared, x, constant, and dot, dot, dot in both sides. If I'm missing a term, I have to say plus 0 of the term. If I have them out of order, I have to put them in descending order for this to work. So we have a few rules that we have to abide by. I notice these go 3, 2, 1 constant, and I do have a nice normal divisor here, so I'm just going to throw my numbers in. 2, 3, negative 4, 15. I always use the opposite of whatever number's inside, so I have my problem set up. To start it off, I'm going to bring this number down, multiply it by the number outside, and I get a negative 6 right here. Now I'm going to add down and get a negative 3, which I'm again going to multiply by this outside number to get a positive 9. You don't have to show all the arrows or all the steps. I just like to. It helps me remember where I'm at. I add down and get a positive 5. And then I multiply again to get a negative 15. Now this one is nice because when I add down, I have a remainder of 0, which makes us happy. Doesn't always happen, but it makes us happy. Again, because I started out with an x to the third, that means that whatever answer I have is going to start with an x squared. From there, I just fill in the blanks. And no remainder means I don't have to put plus 0 on anything. So there is my answer. And you can check these using long division, but I assure you synthetic works well as soon as you start to see it. All right, the last one we have is a special case. And you'll notice the reason that it's special is because this is not in our usual form of x minus n. Why is it not in that form? Well, because it has a 2 out in front of the x. In order to put it in that form, what we're going to do is change our equation just a little bit. We're going to divide everything in our equation by 2. The whole thing. Not just this piece, this whole thing. Why are we going to do that then? Well, because that allows us to get rid of the 2 in front of the x. So let's see what happens. We're going to get 4x to the 4th minus 2x squared, plus 1/2 x plus 2 divided by x plus 1/2. I'm going to put that in parentheses. Now, you should see before I start synthetic division, we have one other problem we have to deal with. We dealt with the 2 in front, so now it's in that nice form that we like. But as you're going along this, you should notice that we're missing the cubed term. So when I start my long division, I have to put a placeholder in. I'm going to start with my x to the 4th, but before I go to my negative 2, I have to put a 0 in to stand in for my missing cubed term. Again, division has to go in order. So we have to make sure we have that accounted for. All right, now that it's all set up, we take the opposite of what's inside and we go to work. 4 comes down. 4 times negative 1/2 is negative 2. Negative 2 times negative 1/2 is positive 1. Add down, I get negative 1. Negative 1 times negative 1/2 is a positive 1/2. 1/2 plus 1/2 is 1. 1 times negative 1/2, negative 1/2. And then I'm left with 3/2. I know that I started out with one number, so I section one off to be my remainder, and then I finish my problem. I started out with an x to the 4th, so I end with an x to the 3rd. Minus 2x squared minus 1x plus 1, and then it will be plus, this one's a little tricky because it's 3/2 over x plus 1/2, which looks a little weird. So I'm going to change that up, simplify it just a little bit so that it is 4x cubed minus 2x squared minus x plus 1, and then plus 3 over 2x plus 1, just to make it a little more simple. All right, hopefully you caught all of that. Synthetic division can take a little bit of practice, so don't get discouraged if you don't get it at first. I think you'll find that once you get good at synthetic division, it's a lot faster than long division. And it was actually one of my favorite things to learn in Algebra 2 when I was in high school. So, hope you enjoyed as much as I do. If you have any questions, let me know. If this video wasn't enough, Khan Academy has a great video on synthetic division, and I would highly recommend you check it out.